Okay, let's talk about the zinc iodide reaction using Legos because it's fun. If I had 2 grams of this and 2 grams of iodine, wouldn't you think that it would make 4 grams of zinc iodide? It's a pretty good logical explanation. But it turns out when you added zinc and iodine together, you ended up with 2.5 grams of zinc iodide. So it's almost like you had this, which is kind of weird. So the question is how did this happen? And the way it is the way to explain it is by using a model of atoms as particles. So the mass doesn't quite give us any information about how many particles there are, but the molar mass converts between moles, mass of particles, and moles of particles. So we apply the molar mass of I2, and it turns out that I2, iodine, has a mass, a pretty big molar mass, like 200 and something, and the mass of one of them is pretty big. So in 2 grams, there's only a couple of those. And it turns out the molar mass of zinc is pretty small, like 65, and in 2 grams, you end up with a lot of them. Okay. But the second piece of the puzzle is that zinc and iodine reacts to form a reaction. They react to form a product called zinc iodide, and it's basically made up of 1 zinc and 1 I2, and that makes ZnI2. That's the equation. Zn plus I2 gives you one of these guys. Okay? That's what you get. So looking at this, you can see which one of our ingredients runs out first. Only when we know the number of particles can we figure this out. Only by finding the moles of what we have can we see, oh, look, we're going to run out of the iodine way before we run out of zinc. And that's exactly what we saw in the lab. We had them react, and all of the iodine reacted. Okay. And we had a bunch of leftover zinc. And the cool thing is if we calculated the number of zinc particles before and then the number after, we actually had a certain number of moles. And if we converted that to grams, it would weigh the exact same, it'd have the same mass as the moles, it would have the same mass as the zinc that we had in the end after our reaction was done. So that's kind of cool. The second piece is that if we knew the number of moles of our limiting reactant, say if there was 2, we could predict that there would be 2 zinc iodide molecules. And we could find the mass of those zinc iodide molecules. And the exact same thing happened in our lab, actually, is that we predicted, we found out how many moles of I2 there were, and we knew it was a 1-to-1 ratio, so the moles of product should be the same. So it's something like, if this was like 0.5 moles, if we had, say, 0.5 moles of I2, we know that we need a total of 0.5 moles of zinc to make 0.5 moles of ZnI2. Okay. All right, so there it is. Hopefully this helps, and hopefully it makes science something that you love. That's kind of a heart, but I don't know if I succeeded at that.